Hello, friends and fellow researchers. I am Eddie Seva. I am going to discuss this time Cyril Hoyt reliability using Excel. Reliability refers to the consistency with which a research instrument measures something. We have available different measures of reliability, one of which is Pearson R for the test reliability. We also have Kuder-Richardson for internal consistency reliability. Again, we have Pearson R for the alternate or parallel form reliability. We also have Cronbach alpha for internal consistency reliability. But our discussion will focus solely on Cyril Hoyt method for internal consistency reliability. We will proceed directly to the illustrative example. Mr. VMGO was tasked by Miss VMGO to determine the awareness of the students of the university on the school's vision. Mr. VMGO constructed an instrument with 10 items, each with only one correct answer. 1 is the score for the correct answer, 0 is for the wrong answer. That will measure the student's knowledge on the matter, and administered it to 16 randomly selected students. These are now the results of the test inputted in an Excel sheet. So you will see for the columns titles, the test items from Q1 to Q10. And we have 16 participants. The scores are either 1 or 0. Mr. VMGO is to determine the reliability of the test instrument using this data and employing Cyril Hoyt coefficient of reliability, ANOVA variation method. So take note very well of the formula and supportive formulae shown on the screen. The formula requires the determination of, among others, rows totals and the columns totals. To determine the sum of the columns or for the items, click your pointer at a sum box, for example, L3, and type equals sum B3 colon K3 and click out. Do the same to the rest of the column sum boxes. To determine the sum of the rows or the participants, click your pointer at a sum box, for example, B13, and type equals B3 colon B19 and click out. Do the same to the rest of the row sum boxes. The formula also requires the determination of the square of each column sum. To do this, click your pointer at the square of a column sum box, for example, M3, and type equals L3 caret 2 and click out. Do the same to the rest of the squared column sum boxes. The formula further requires the determination of the square of each row sum. To do this, click your pointer at a squared row sum box, for example, B20, and type equals B19 caret 2 and click out. Do the same to the rest of the squared column sum boxes. With all those sums and squares of sums done, these are now the programming encodes in the Excel cells or boxes, which you need to carefully check and analyze. You can either pause or rewind this pause to review your encodes. The programs and solutions are inputted in columns N, O, P, and Q. This value that appears in Q2, 0.89371, is a very good reliability, with few items in the instrument needing improvement, but describes the instrument based on data taken from 16 participants only, and is true insofar as this sample is concerned. Will this reliability be correct to the entire population? To find out, it must be subjected to F-test. Inasmuch as this solution has already been programmed, you can use this Excel sheet for data from tests with 10 or less items administered to 16 or less participants. All you have to do is to change the data entries and your program will automatically recompute. Thank you for listening and viewing.